So this is Unit 17 of Human Immunity. In this PowerPoint I'll be talking about infection, types of responses, the first, second and third line of defence, types of cells, recognition, tolerance and transplants, immunity disorders, acquired immunity and vaccinations and their concepts. So what is human immunity? So it's when your body's organs, cells and proteins work together to defend itself from infection. It'll also create a memory after it has responded, just in case it happens again. An infection, they come in all sorts of different shapes, sizes, strengths, all sorts, and they're also called pathogens. And the part of a pathogen is called an antigen, which they're the bits that hook on to the cells or organs. They come in 4 different types, so bacteria, virus, fungi and parasites. So we have bacteria, which love to thrive in temperatures of between 5 degrees and 60 degrees. Anything lower or higher will either kill or stop them. Then we have viruses. So viruses aren't living, so they have to find a host to be able to replicate. And we have coronavirus, AIDS, influenza. We have fungal infection. They're really rigid and they replicate by spreading all sorts of spores across your skin, lungs and nervous system. We have parasites, which mainly come from animals, and they attach themselves to the skin and penetrate that infection that way. Types of transmission, you have direct, which is person to person, indirect, so touching of surfaces, insect bites, and food consumption, which is food poisoning, allergic reactions. So the first line of defence is a non-specific response to a pathogen. You are born with the first line of defence, so it's nothing that you have to learn over time. You have your physical barriers, which is your skin, tears and mucus. Your chemical barriers, which are white blood cells and proteins. So your skin is the biggest organ of the human body. It protects us from all sorts of different irritants. It is compressed into 3 main layers. So you've got your epidermis, which is the outer waterproof layer. The dermis, which is the thickest layer, contains the sweat glands, roots and your nerves. And then you've got the subcutaneous, which holds all your blood vessels and protects your muscles. So this is a diagram, and as you can see, you've got the 3 kind of distinct layers of your skin. You have the second line of defence, which includes inflammation, fever, pathocytes, proteins and cytokines. Now, this is what happens, your body's response, if an infection manages to penetrate the first line. So starting off with inflammation, this is what happens when a part of your body becomes infected or cut or anything like that, and you will see swelling. It will become red, very painful and very warm. This is due to the fact that your blood vessels, which contain heat, will dilate and allow the blood to flow quicker to the site that it needs to respond to. So this is more of a visual of how what happens during the process of inflammation. We also have fever, so your body will raise its temperature higher than 37 degrees in response to be able to stop the bacteria or virus from growing. in order to find a response quicker. Then you have your white blood cells that will manipulate themselves to respond to certain scenarios, and then you have other white blood cells that are called cell eaters, and they basically eat dead cells, pathogens, and digest them. So this is like the process of white blood cells. Then we've got complement proteins. There are a range of large blood cells which aid in the refueling of the white blood cells when a response is needed. Then you've got your cytokines, which are small messengers that help your immune system to tell your body that it needs defending, and they come in all different types of proteins. Then you have the third line, which is also called an acquired system. This is something that your body will learn over time. The more time it gets infected, the bigger the memory. You can get artificially acquired immunity, which is a vaccine, and this will purposely expose your body with an infection. Then you have the different types of immune cells, which is neutrophils, which attach themselves, lymphocytes, which are supporting cells, monocytes, which work alongside the cell eaters, eosinophils, which is they send the messages, and basophils, which dilate the blood vessels. You have T cells and B cells. So a B cell is part of a T cell, which they are the cells that help grow the proteins and help respond in the immune system. Then you have immunoglobulin. These cells are very similar to antibodies, but they are structured differently, so they're like a Y, and they target the infection, and there are many ranges of them, and they range from IgA to IgM. Then we have tolerance, transplants and disorders. So your body will recognise a healthy cell and a bad cell, but sometimes it can struggle, especially if it has a disorder to your immune system. If your immune system has a disorder, it will work alongside certain cells to be able to recognise the differences. So many people are sensitive to antigens. You have people who have very sensitivity, which can take either too long or it can respond way too quickly and get it wrong and attack the wrong cells. Then you've got hypersensitivity, which when your immune system is faced with the same infection and can't figure out if it's bad or good. Then you've got autoimmunity, which your body generally cannot distinguish between the two and end up attacking itself. So your body will randomly generate different responses and cells and create what is called a pool, which will open when your body is faced by an infection, and sometimes this can fail. So this is where the B and T cells basically get involved. So transplants, it is the transfer of tissues, cells and organs. They're incredibly difficult to match sometimes, and they also run the risk of being rejected, as they are classed as a foreign body. So the rejection, it can happen in the first 6 months, and it will happen from time to time. So to be able to match properly, many tests from the donor will happen. So tissue tests, the same blood type, antibodies are matched, all sorts, to be able to have a successful transplant. And then you have other antibodies that are used during to basically to get rid of the original T cells. Types of rejection. So you've got hyperacute, which is minutes after a surgery has happened. It will either attack or take, and if it attacks, normally due to the wrong blood type, it has to be removed, as it can be life-threatening. Then you have acute rejection. Acute rejection happens to everybody, and it's basically a way to show that your immune system is still working. And then you have chronic rejection, which happens over a long period of time, and the body will constantly attack and cause damage to the organ. So many people have immune system disorders, which is obviously when your body can't distinguish between healthy cells and bad cells. But it is very easy diagnosed, and I'm going to go through some of the quite common disorders. So you have eczema, which is mainly attacks the skin, and it becomes very dry, flaky, painful, itchy, and it can spread anywhere. And then you have asthma, which is also incredibly common, and it affects the airways and the lungs if you are allergic to mainly dust or have like very bad viral infections. You also have lupus. Lupus is a very severe immune system disorder that mainly affects your blood, your kidneys and your joints. It can cause very painful limbs. You can become very tired. You can get a very serious rash across your face. There is no cure, so you do have to have just treatment to reduce pain, the rashes, and basically deal with it as best as you can. So causes are puberty, pregnancy, and menopause, as it's mainly found in women. You can get mild, moderate and severe, which is life-threatening, and triggers are spending time in direct sunlight, long periods of time, unhealthy diets and smoking. Then you have Crohn's disease. This is an immune system that affects the bowel. It's very painful, weight loss, diarrhea and blood in stool. The causes of Crohn's is very severe stomach bugs, abnormal amounts of gut bacteria, and it is passed through genetics. There is no cure, but surgery is a very positive suggestion for people that do have Crohn's disease, and very strict diets as well. So you have an acquired immune system, and this is how the body learns how to defend itself in different ways. So you have active immunity, and this will gain resistance to specific illnesses. You've got natural active immunity, which is the body will naturally create antibodies, and then you've got artificial immunity, which is almost like a vaccine, so it will give you a small amount of infection and then your body will forcefully respond. Then you have passive immunity. So passive immunity is natural mainly between mother and unborn child, through either the placenta or through breastfeeding. Then you've got artificial, which doesn't last very long, but it's through like blood transfusions, injections, and can only protect for a certain amount of time. So here's just like a comparison between active and passive. So your immune system's response to vaccines. So your body will be exposed to a very, very weakened, harmless version of an infection, which will contain fragments of the infections, dead cells or toxins, and you may sometimes suffer mild symptoms. But this is what happens when your body will then create the memory of the response. You have live and inactive vaccines. So live vaccines are produced by weakening a wild disease in a laboratory and hope to produce a response. And then inactive vaccines are produced by maturing a bacteria and then stopping the replication before it becomes harmful. But this is something that is needed of multiple doses. You have something called herd immunity. This is what happens when a community is faced with an infection, but more people are vaccinated than not. So it will basically stop the spread as it has nowhere to go. It can obviously fail as well, so that obviously increases the number of cases. It's always a very good idea to isolate the infected, as it's not just protecting you, it's protecting them as well, to also stop the spread. You have an immunity threshold. Now this is something that basically is how you calculate a vaccine and how responsive and effective it's going to be. And then you have the benefits and the problems of having a vaccine. So it's helping your immune system, it's teaching it, it takes pressure off the NHS. But then you do have problems which people are influenced by social media, but then it's also down to somebody's religion and cultural benefits basically. And that's the end of my presentation. Thank you very much.